In here, we got a new article from NASA James Webb Telescope, which says here that NASA's Webb finds signs of possible aurora on isolated brown dwarf. And this here shows 4 key points to take away before we dive into the specifics of this incredible result here by James Webb Telescope. The first point being that astronomers uses the NASA's James Webb Telescope that is really great at, in this case, not only discovering the brown dwarf, but most importantly using its infrared emissions from methane to be able to understand more about the energies in its upper atmosphere. Now, in addition to this brown dwarf specifically is designated to be W1935, and this here is cold and it lacks a really hot or host star that is really an unexpected discovery from James Webb Telescope team, which is in this case the astronomers. Now, the third point here is that the team speculated that the methane emission may be due to processes that is generating this array, and this methane in emission is a common features in gas giants, like for example looking at Jupiter, looking at Saturn, and the upper atmosphere heating that powers this emission here is linked directly with the aurora. Now, for specifics on this incredible result here, this says here the following. Now, looking closely at home, in this case of how our auroras are actually generated. In here, it says here that it is created when energetic particles from the sun are captured by Earth's magnetic field and cascades down into our atmosphere along with magnetic field lines near Earth's poles, thereby colliding with gas molecules and creating area. And this here is kind of like a nice beautiful dancing curtains of lights that are shown here. And now this here, now looking at all the planets, shows that for example Jupiter and Saturn, they have similar auroral processes that involves interacting with the solar winds, but in this case here they also get auroral contributions from nearby active moons that are around those planets. And this here specifically for Enceladus, that is more closely linked to Saturn, but for Jupiter its moon is known as, or is called Io. I don't know what that is, but that's pretty interesting. Now, furthermore, for isolated brown dwarfs, like for example this particular brown dwarf, the absence of a stellar wind to contribute to the aurora process and explain the extra energies in the upper atmosphere required from the methane emission is a total mystery, because from the very first statement it says here that this brown dwarf is not in any way close to any star to produce that stellar winds. So the team in this case, they surmises that either an unaccounted internal processes like the atmospheric phenomena of Jupiter and Saturn, where their moons are contributing to this, or external interactions with interstellar plasma may help account for this specific emission. In terms of how they arrived at this result here, there were a team that was led by Jackie Fatty, who is an astronomer at the American Museum of Natural History in New York City, where he was invited and his team to explore 12 brown dwarfs, but this includes this huge comparison, one between the W1935, which is what we just are talking about, but also another one which was discovered by James Webb Telescope, which is W2220. Now, W1935 was actually discovered by a civilian, and that is pretty impressive to actually acknowledge that. But in here, based on similarities that were really hugely incredibly detected comparing these two brown dwarfs, not only in terms of, according to this article here, states that this here showed that there are really incredibly clones of each other in terms of the composition, sharing the same brightness, temperature, and spectral features of water, ammonia, carbon monoxide, and carbon dioxide. Now, the only difference here between these two brown dwarfs are the presence of methane, and in here it says that the W1935 showed emissions from methane as opposed to the anticipated absorption feature that was observed towards the W2220. Now, the team used computer models to infer what might be behind the emission, and the modeling work shows that the W2220 had an expected distribution of energy throughout the atmosphere. Now, this is causing a generating of the colder with higher altitude, and in contrast here, which is the W1935 here, in here this had surprising results, and the best model favored a temperature inversion where the atmosphere got warmer with higher altitude. Now, this temperature inversion is really puzzling, definitely for sure, because one shows colder at higher altitude and the other one shows higher in temperature at higher altitude. This actually seems this kind of phenomenon in planets with a nearby star that can hit the stratosphere. Now, this here is seeing it in an object with no obvious external heat source is wild. And this here is according to a co-author from the University of Hertfordshire in England. His name here is Ben Birmingham. Now, when we look at the behavior of this specific brown dwarf, we look at our solar system to figure out what planets or bodies actually exhibit this interesting phenomenon that is happening right here. And we can look no further than Jupiter and Saturn, of course, and this here can be a proxies, according to this article, to see what is actually happening or explain what is happening 40 light years away from us in that particular brown dwarf's atmosphere. And so the team here, according to this article here, realized that the temperature inversions in terms of comparing the two brown dwarfs here are prominent in planets like, for example, Jupiter and Saturn, and this is still ongoing work to understand the cause of this stratospheric heating, and this here will lead to theories for the solar system that involve external heating by Aurora or internal heating transport from deeper in the atmosphere. In conclusion, here are 5 points to take away from this particular article. First is that astronomers have detected, of course, auroras through radio emissions that are coming from several warmer brown dwarfs, and this here is most likely the explanation for those brown dwarfs. Now, for this specific brown dwarf, which is W1935 here, this is the first auroral candidate outside our solar system with a signal of methane emission, not the other ones with radio emissions. And so this also shows the coolest aurora candidate outside our solar system with an effective temperature of about 400 degrees Fahrenheit, which is around 200 degrees Celsius, and about 600 degrees Fahrenheit warmer than that of our solar system planet, which in this case is Jupiter. Now, in our solar system specifically, the solar winds are really the primary contribution of auroral processes, with active moons like Io and Enceladus, which play a role in planets like Jupiter and Saturn respectively. Now, in this other case here, for this brown dwarf specifically, there is a lack of a stellar wind coming from its own sun, because there is no sun at all where this particular dwarf is located. Therefore, that doesn't help in this phenomenon here that is happening in this particular brown dwarf's atmosphere. Now, this is yet to be seen where the active moon might play a role in this particular emission, or methane emission on this particular brown dwarf. Now, with this particular brown dwarf here, we now have a spectacular extension of the solar system, which is the temperature inversion here, and this here is without any stellar irradiation to help in this explanation. Now, this here, according to Ferretti, noted that with Webb we can really open the hood on the chemistry and unpack how similar or different the auroral process might be beyond our solar system. So, really incredible stuff here based on this article concerning how auroras are generated from this particular brown dwarf right here. Let's know your thought about this in the comment section down below about this particular phenomenon here based on how the aurora are generated through methane emission here, and let's know your thought about this in the comment section down below. All the same, glad to hear from you. Talk to you soon. As always, stay smart and believe in yourselves.